Good evening, and welcome. This is your host, the Electric Starman. Tonight, we leave the warmth of our terrestrial home and follow two lonely pathfinders into the deep freeze of interstellar space. Before the Voyager probes made their grand tours, there were the Pioneer twins, Pioneer 10 and Pioneer 11. Launched in the early 1970s, these identical, compact craft were humanity's first true scouts sent into the outer solar system. They were the first to brave the rocky debris of the asteroid belt. They were the first to send back close-up images of Jupiter's swirling, chaotic atmosphere, and in the case of Pioneer 11, the first to lay eyes on the majestic rings of Saturn. But their journey did not end at the planets. Driven by the unyielding laws of celestial mechanics, they were slung into trajectories that carried them permanently away from the sun. Today, they are entirely silent. Pioneer 11 sent its last, faint transmission in November of 1995. Pioneer 10 whispered its final, barely legible data packet across the dark in January of 2003. They are drifting now, completely dead, carrying a message from an era of Earth that has already slipped into history. In this exploration, we will look closely at the physics of their isolation. We will examine the delicate, gold anodized plaques they carry, etched with the coordinates of our home. We will unpack the mystery of the Pioneer anomaly, a tiny, ghostly deceleration that puzzled astrophysicists for decades. And we will trace their paths across the ultimate shoreline, where the solar wind dies and the interstellar medium begins. We are tracing the path of the silent twins. The year is 1972. A small assembly of metal, cables, and glass sits at the tip of an Atlas Centaur rocket. It is Pioneer 10. It weighs just under 260 kilograms. It is a fragile thing, constructed of aluminum alloys, looking like a brilliant silver dish antenna resting on a delicate hexagonal frame. Its mission is to go where nothing human has ever gone before. It must cross the great, empty expanses between Mars and Jupiter. It must test whether the solar system will allow us to leave. The launch is violent, a brief burst of chemical energy that tears through the thin layer of Earth's atmosphere. But within minutes, the violence ends. The rocket drops away. The craft is left in an absolute, profound silence. It is moving at over 50,000 kilometers per hour, the fastest human object ever launched up to that moment in time. The Earth behind it begins to shrink. It becomes a blue crescent, then a bright dot, then a pale speck lost among the background stars. Ahead lies the asteroid belt. In 1972, scientists do not know if this region is an impassable wall of grinding rock. They fear that millions of invisible pebbles, moving at hypervelocity speeds, will shred the spacecraft's delicate skin The space is vast, but the anxiety is deep. Pioneer 10 enters the belt. It drifts through the debris field for 7 long months. Day after day, the sensors record nothing but emptiness. The gaps between the asteroids are vast, measuring millions of kilometers of true vacuum. Craft moves through the silent dark, untouched. By December of 1973, Jupiter grows large in the narrow field of view. The gas giant is a towering, turbulent world of amber, ochre, and deep crimson. This specific color palette is a complex chemical fingerprint. The deep reds and oranges are not the result of solid terrain, but rather the interaction of solar ultraviolet radiation with trace elements of ammonium hydrosulfide and complex organic polymers known as tholins. These gases rise from the deep, high-pressure interior of the planet, forming vast, cyclical convective cells. They absorb the blue and green wavelengths of the distant sun, reflecting only the long, warm wavelengths of the spectrum. It is a beautiful, toxic canvas, turning slowly in the dark. Pioneer 10 plunges into the planet's magnetosphere. This is a region of intense, invisible violence. The magnetic field of Jupiter is millions of times stronger than Earth's. It traps high-energy electrons and ions, creating a screaming wall of synchrotron radiation. As the spacecraft approaches its periapsis, the radiation levels spike to thousands of times the lethal limit for a human being. The delicate silicon transistors inside the craft's computer systems begin to degrade. The telemetry data arriving back on Earth becomes erratic, filled with static and missing bits. The digital circuits are experiencing radiation-induced bit flips. Yet, craft holds together. The engineering is robust. It skims just 130,000 kilometers above the swirling cloud tops of Jupiter. The immense gravity of the giant planet catches the small craft in a profound, invisible embrace. It accelerates the probe, bending its path, acting as a celestial slingshot. The spacecraft is thrown outward, gaining kinetic energy from the orbital momentum of Jupiter itself. It is cast toward the outer perimeter of the solar system, set on a trajectory that ensures it will never return to the sun. One year later, in December of 1974, Pioneer 11 follows the exact same path. It approaches Jupiter from a different angle, diving even closer to the planet's cloud tops, skimming just 43,000 kilometers above the swirling atmosphere. It braves an even more intense bombardment of radiation. The spacecraft's instruments are pushed to their absolute physical limits, measuring the magnetic flux lines and the density of the Jovian plasma. It uses the massive gravitational well of Jupiter not just to accelerate, but to completely redirect its flight path. It is slung across the width of the solar system, directed toward a rendezvous with Saturn. The two craft have now begun their long, diverging journeys into the dark. On the framework of both Pioneer 10 and Pioneer 11, shielded from the direct impact of cosmic dust, lies a small sheet of gold anodized aluminum. It measures 22 centimeters by 15 centimeters. It is a message, prepared by Carl Sagan and Frank Drake, designed to survive for hundreds of millions of years in the vacuum of space. The metal is smooth, colored a pale, warm gold due to an electrochemical anodization process that thickens the protective oxide layer on the aluminum surface. It carries no words, no language from our shifting human tongues. It speaks only in the language of physics and mathematics. At the top left of the plaque is an etched diagram of the most abundant element in the universe, hydrogen. The diagram shows two small circles, representing the hyperfine transition of neutral atomic hydrogen. Each circle contains a line indicating the spin orientation of the proton and the electron. In one circle, the spins are parallel. In the other, the electron has undergone a spin-flip transition, its spin now anti-parallel to the proton. This simple quantum mechanical event is a universal clock. When the electron flips, it emits a photon with a highly specific wavelength of 21 centimeters and a frequency of 1420 megahertz. This 21 centimeter line is the key that unlocks the entire message. Beneath the hydrogen diagram is a binary digit, a simple vertical line representing the number 1. This tells any extraterrestrial finder that the length of this wave, 21 centimeters, is our fundamental unit of distance. The time it takes for that photon to complete one cycle, a fraction of a nanosecond, is our fundamental unit of time. It is an intellectual bridge built across the vacuum, using the fundamental constants of the cosmos to establish a shared understanding. To the right of the hydrogen diagram is a radiating starburst pattern of lines. This is the pulsar map. 14 lines radiate outward from a central point, which represents our sun. Each line is a vector, its length corresponding to the relative distance of a specific pulsar from our solar system. Along each line, long strings of binary numbers are etched. These numbers do not describe distances, they describe time. They represent the precise rotational periods of 14 distinct, rapidly spinning neutron stars, measured using the fundamental clock of the hydrogen atom. A pulsar is a cosmic lighthouse. It is the collapsed core of a massive star, spinning multiple times per second, emitting a highly focused beam of electromagnetic radiation across the cosmos. Because these neutron stars lose rotational energy over time, their periods slowly, predictably increase. The pulsar map etched into the gold plate is therefore not just a map in space, it is a map in time. A sufficiently advanced civilization, finding the plaque millions of years from now, can read the periods of the pulsars, calculate how much they have slowed down, and determine precisely when the spacecraft was launched. It is a cosmic timestamp, frozen in gold. At the bottom of the plaque is a simple schematic of our solar system. It shows the sun, a large circle, followed by 9 smaller circles representing the planets and their relative orbital distances. A tiny line curves away from the third planet, passing by Jupiter and pointing out into the void. It shows where the tiny messenger came from. Beside the diagram of the solar system are the outlines of a human man and woman, drawn standing in front of a silhouette of the spacecraft. The man's hand is raised in a gesture of peace, a universal sign of goodwill, though its meaning may be entirely lost on a creature that evolved under a different star. The figures are drawn to scale against the silhouette of the probe. By comparing the height of the human forms to the physical dimensions of the spacecraft, any entity that intercepts the craft can deduce the physical size of the beings that built it. The lines are etched clean and deep into the gold anodized surface. There is no air in the interstellar void to oxidize the metal. There is no moisture to cause corrosion. The plaque will drift through the freezing vacuum, a silent, beautiful monument to an era when a young species first reached its hands out into the dark. As the Pioneer twins moved past the outer planets, scientists at the Deep Space Network noticed a strange anomaly in the tracking data. It was a phantom force, a tiny, unexplained deceleration that seemed to be pulling both spacecraft back toward the sun. The effect was minuscule, an acceleration of just 8.74 times 10 to the minus 10th meters per second squared. It meant that every year, the spacecraft were falling behind their predicted positions by about 5,000 kilometers. It was named the Pioneer Anomaly. For decades, this tiny discrepancy sparked intense debate among the world's finest physicists. Some suggested that the craft were experiencing the gravitational pull of dark matter hidden in the outer solar system. Others argued that the data revealed a flaw in our understanding of gravity itself, suggesting that Isaac Newton's inverse square law or Albert Einstein's general relativity required a slight modification at immense distances. The telemetry data was analyzed with agonizing care, accounting for the gravitational pull of the planets, the pressure of the solar wind, and the mass of the Kuiper Belt objects. The anomaly remained obstinate, constant, and unexplained. The mystery was finally solved not by discovering new physics, but through a painstaking study of engineering thermodynamics. The Pioneer spacecraft are powered by radioisotope thermoelectric generators, or RTGs. These units contain capsules of plutonium-238 dioxide, a radioactive isotope that decays via alpha emission, releasing a tremendous amount of thermal energy. Thermocouples convert this heat into electricity to run the spacecraft's instruments. However, only a fraction of the thermal energy is converted into power. The rest must be radiated away into the freezing vacuum of space as infrared photons. The key to the anomaly lay in the geometry of the craft. The large, parabolic, high-gain antenna faces directly back toward Earth, which means it also faces generally back toward the Sun. The RTGs are mounted on long booms extending out from the sides of the craft. As they radiate their immense thermal energy, some of those infrared photons strike the back of the large antenna dish. The photons bounce off the dish and are directed out into space, away from the Sun. A photon carries a tiny, infinitesimal amount of momentum. When billions of these infrared photons recoil off the back of the antenna dish in a specific direction, they exert a continuous, asymmetric thrust. It is a manifestation of conservation of momentum, a subtle thermal radiation pressure. The force is incredibly small, equivalent to the weight of a single grain of sand resting on your palm. But applied continuously over decades, across billions of kilometers of flight, this asymmetric thermal recoil was enough to drag the spacecraft off their calculated courses. The phantom force was nothing more than the heat of the spacecraft's own dying nuclear hearts, pushing against the metal dishes. By the dawn of the 21st century, that heat was fading. Plutonium-238 has a half-life of 87.7 years. Every year, the amount of radioactive material inside the capsule decreases and the temperature of the RTGs drops. The electrical power available to the spacecraft's transmitters dwindles by a few watts annually. One by one, the automated systems on Earth watched the telemetry fade. The signals received by the massive 70-meter antennas of the Deep Space Network became incredibly weak, requiring sophisticated digital filtering to separate the spacecraft's voice from the crackling, cosmic microwave background radiation. On January 23, 2003, Pioneer 10 sent its final transmission. It was over 12 billion kilometers from Earth, a distance of 82 astronomical units. At that distance, radio waves traveling at the speed of light took over 11 hours to complete the one-way journey home. The signal arrived as a whisper, carrying no science data, only a faint carrier wave. It was a digital heartbeat, flatlining into the static of the interstellar medium. The engineers listened, recorded the final telemetry frame, and then there was nothing but the silence of the cold sky. The year is 1974. Pioneer 11 leaves the massive gravitational well of Jupiter behind. It has been slung into a long, quiet arc across the deep solar system, directed toward a completely unprecedented destination. Ahead lies Saturn. It will take 5 years of silent coasting through the dark to reach the ringed planet. 5 years of absolute stasis, where the spacecraft moves through an environment devoid of landmarks. The sun behind it shrinks further, its light dimming, its warmth fading into a faint memory. The probe is a lone, mechanical traveler, falling through a cold, frictionless expanse toward a rendezvous with a giant world. As the years pass, Saturn slowly transforms from a bright, golden point of light into a massive, three-dimensional sphere. The planet dominates the narrow field of view of the imaging photopolarimeter. It appears as a soft, muted gold, a hazy, saffron world wrapped in thick, horizontal bands of cloud. The color is a complex, spectroscopic signature. The upper atmosphere is composed primarily of hydrogen and helium, but it is covered by a high-altitude shroud of ammonia ice clouds. Beneath these icy crystals lies a deeper layer where trace amounts of phosphine gas rise from the high-pressure interior. When solar ultraviolet light strikes this phosphine gas, it undergoes photolysis, breaking down into complex phosphorus polymers. These organic chemical compounds absorb the shorter, blue and violet wavelengths of starlight, reflecting only the warm, gold and ochre tones back into space. It is a world cloaked in photochemical smog, turning slowly in the absolute dark. The true marvel of the encounter is the approach to the rings. Before 1979, humanity has only viewed Saturn's rings through the distorting lens of Earth's atmosphere. They appear from afar as smooth, continuous sheets of light. Pioneer 11 dispels this illusion. It approaches from beneath the ring plane, viewing the unilluminated side of the ring system. From this specific perspective, the rings undergo a dramatic visual inversion. The dense B ring, which appears brightest from Earth because it reflects the most sunlight, appears completely black to the spacecraft. It is so thick, so densely packed with material, that it blocks the sunlight entirely, casting a deep, absolute shadow across the winter hemisphere of the planet. Conversely, the faint, sparse rings appear bright as sunlight filters easily through their open structures. The rings are not solid structures. They are an epic, dynamic system composed of billions of individual particles of water ice, ranging in size from microscopic dust grains to house-sized boulders. Each particle is an independent satellite, orbiting Saturn in perfect accordance with Kepler's laws of planetary motion. As Pioneer 11 skims just 21,000 kilometers above the cloud tops, it plunges directly through the outer perimeter of the ring plane. It is a moment of extreme engineering peril. The spacecraft is moving at over 100,000 kilometers per hour relative to the rings. A collision with a particle even the size of a pebble would be fatal, instantly shattering the delicate aluminum skin of the probe. Instead of disaster, the crossing yields discovery. The spacecraft's instruments detect a narrow, previously unknown ring structure existing outside the main A-ring. It is designated the F-ring. This narrow band of icy debris is held in place by the complex gravitational choreography of two small shepherd moons, Prometheus and Pandora, which orbit on either side of the ring. The moons exert a continuous, cyclical gravitational pull on the ring particles. One moon accelerates the particles, forcing them into higher orbits, while the other decelerates them, dragging them lower. This constant, invisible herding creates waves, kinks, and braids within the structure of the F-ring, a manifestation of orbital mechanics acting on a cosmic scale. On September 1st, 1979, Pioneer 11 achieves its periapsis, passing through its closest approach to Saturn. The massive gravity of the planet grips the small craft, bending its flight path with immense force. The encounter is a masterwork of celestial trajectory design. The probe uses the orbital momentum of Saturn to execute a high inclination gravity assist. It is slung upward, out of the flat ecliptic plane where all the planets reside. It is tilted at an angle of 12.6 degrees relative to the rest of the solar system. This maneuver ensures that the craft will never encounter another planet. It has been thrown into a solitary, upward trajectory, ascending into the dark, empty sky above the solar system, set on a permanent path toward the stars of the constellation Aquila. Deep space is an environment of absolute thermodynamic hostility. As the Pioneer twins drift past the outer boundaries of the solar system, they move further away from the sun's ambient warmth. The temperature of the structural panels drops towards the cold equilibrium of the interstellar void, hanging just a few degrees above absolute zero. At this immense distance, solar panels are completely useless. The sunlight is too weak, too attenuated to generate electrical current. To survive in this frozen stasis, the spacecraft must rely on an internal, independent source of energy. They carry their own nuclear fires. Mounted on long, extended trusses, designed to isolate the spacecraft's delicate scientific instruments from radiation, are 4 SNAP-19 RTGs, or radioisotope thermoelectric generators. These units are compact, cylindrical containers fitted with wide, white, heat-radiating fins. Inside the core of each generator sit small capsules of plutonium-238 dioxide. Plutonium-238 is an unstable, man-made isotope that undergoes continuous, spontaneous alpha decay. With a predictable rhythm, the unstable plutonium nuclei fracture, each atom ejecting an alpha particle, a tightly bound cluster of 2 protons and 2 neutrons. This alpha decay is a process of pure nuclear transformation. The ejected alpha particles are moving at highly significant velocities, possessing considerable kinetic energy. As they travel through the dense material of the fuel capsule, they continuously collide with the surrounding plutonium and oxygen atoms. With every collision, their kinetic energy is absorbed by the lattice structure of the material, transforming instantly into thermal energy. The fuel capsules begin to glow with a steady, dull, orange-red heat. The core of each generator reaches temperatures of hundreds of degrees Celsius, creating a localized oasis of intense warmth within the freezing desert of the outer solar system. To convert this raw thermal energy into usable electricity, the SNAP 19 generators employ the physics of the Seebeck effect. The walls of the generator are lined with hundreds of individual thermoelectric pairs, or thermocouples, constructed from specialized semiconductor materials like lead telluride. A thermocouple is formed by joining 2 distinct types of semiconductors together. One side of the junction is pressed against the hot, glowing inner core of the plutonium capsule, while the opposite side is connected to the cold outer radiating fins, exposed to the freezing vacuum of space. This architecture creates a steep, continuous thermal gradient across the semiconductor material. This thermal gradient drives a microscopic current. The temperature difference causes charge carriers, electrons in one type of semiconductor and positive holes in the other, to migrate away from the hot junction and accumulate at the cold end. This displacement of charge generates a continuous electrical voltage, a silent flow of direct current that travels along the spacecraft's wiring harnesses to power the main computer, the radio transmitters, and the cosmic ray sensors. There are no moving parts, no spinning turbines, no mechanical friction. It is a system of pure, solid-state physics, converting the decay of an atomic nucleus directly into human communication across the dark. But this nuclear heart is subject to the unyielding laws of radioactive half-life. Plutonium-238 has a half-life of 87.7 years. With every tick of the cosmic clock, fewer plutonium atoms remain to decay. Year by year, the rate of alpha emissions slows down. The fuel capsules grow subtly cooler, and the thermal gradient across the lead telluride junctions begins to flatten. Compounding this natural nuclear decay is the structural degradation of the thermocouples themselves. The constant, intense neutron bombardment from the radioactive core slowly disrupts the orderly crystalline lattice of the semiconductors, reducing their efficiency and increasing their internal electrical resistance. The power output of the spacecraft drops by approximately 5 watts every year. It is an unpreventable slow-motion starvation. Back on Earth, engineers at NASA Ames Research Center watch this decline with analytical detachment. They were forced to engage in a continuous engineering triage. As the available wattage dwindled, commands were sent across the void to shut down individual instruments. First, the imaging systems were deactivated, their lenses staring blindly into the black. Then, the internal heaters were systematically turned off. The inner compartments of the spacecraft began to cool, dropping below freezing. The specialized hydrazine fuel lines froze solid, and the mechanical thrusters went stiff. The spacecraft were slowly petrifying, transitioning from active scientific observers into frozen, inert monuments, drifting silently through the deep. By the beginning of the 21st century, Pioneer 10 had entered a region of space that strains the limits of human imagination. It is 2003, and the spacecraft is over 12 billion kilometers from its home world, a distance corresponding to 82 astronomical units. One astronomical unit is the distance between the Earth and the Sun, a distance that takes light 8 minutes to cross. At 82 astronomical units, the Sun is no longer a warm, blinding disk. It is shrunk to an intensely bright, piercing point of light that provides no perceptible heat. The geometry of the solar system has flattened into a distant, background feature. At this immense distance, the physics of signal propagation becomes an extraordinary engineering challenge. The spacecraft's main radio transmitter operates on a mere 8 watts of power, less than the energy consumed by a small nightlight. This weak radio signal is focused into a narrow beam by the 9-foot-wide parabolic high-gain antenna, directed back toward the predicted position of Earth. As this radio beam travels through the immense vacuum, it obeys the inverse square law of radiation. The beam spreads out continuously, its energy dispersing across a vast, expanding cone of space. By the time the signal reaches Earth, it has spread across an area wider than our entire planet. The power that actually strikes the ground is unimaginably small. When the radio waves encounter the massive 70-meter parabolic dishes of the Deep Space Network in California, Madrid, and Canberra, the received power is measured in zeptawatts. A zeptawatt is 10 to the minus 21st watts. The signal is 1 billion times weaker than the energy required to operate a digital wristwatch. It is a microscopic ripple in the electromagnetic spectrum, completely buried beneath the continuous background hiss of the cosmos. The thermal noise of Earth's atmosphere, the crackle of solar flares, and the ancient echo of the cosmic microwave background radiation. To extract this fragile human whisper from the roaring static of the universe, the Deep Space Network must utilize advanced cryogenically cooled amplifiers. The microwave receivers at the center of the giant dishes are enclosed in vacuum flasks filled with liquid helium, cooling the electronics down to just 4 Kelvin above absolute zero. At this ultra-low temperature, the random thermal vibrations of the copper atoms within the amplifier's circuits are brought to a near-complete halt. This elimination of internal thermal noise allows the highly sensitive maser amplifiers to detect the minute electrical currents induced by the incoming radio waves from the spacecraft. The signal arriving from Pioneer 10 is no longer a dense stream of scientific telemetry. The power is too low to sustain a data link. Instead, it is a pure, unmodulated carrier wave, a single, steady tone oscillating at 2.2 gigahertz in the S-band spectrum. It contains no bits, no measurements, no numbers. It is simply a digital heartbeat, a continuous declaration of existence. Because Earth is orbiting the Sun, and the spacecraft is moving away, the frequency of this carrier wave is subject to a constant Doppler shift. The incoming frequency must be adjusted continuously by ground computers, tracking the minute variations caused by the orbital mechanics of our own planet. On January 23, 2003, the engineers at the Goldstone Tracking Station initiated the final scheduled tracking pass for the Pioneer 10 mission. The spacecraft was dying, its power levels hovering right at the absolute threshold required to operate its transmitter. The giant dish turned smoothly on its azimuth mount, pointing toward a precise set of coordinates in the constellation Taurus. For 11 hours and 11 minutes, the radio waves traveled through the void to reach Earth. The receiver caught the tone. It was an incredibly faint spike on the spectrum analyzer, a lonely peak rising just above the noise floor. The engineers watched the signal for several hours as the spacecraft transmitted its final telemetry frame. The signal-to-noise ratio was dropping continuously as the spacecraft's internal components grew colder. The frequency began to drift erratically as the master crystal oscillator lost thermal stability. Then, with a quiet finality, the signal dropped below the detection threshold of the phase-locked loop. The lonely peak on the spectrum analyzer flattened, dissolving completely into the white noise of the cosmos. The tracking computers searched the frequency band for hours, but there was nothing more to hear. The link was broken. Pioneer 10 was left to navigate the infinite dark alone, a silent ship sailing an uncharted ocean. Although the Pioneer twins are now entirely silent, Their physical journeys are far from over. They are currently approaching the ultimate frontier of our star's empire, the heliopause. This is the true interstellar shoreline, an invisible, dynamic boundary where the dominion of the sun ends and the realm of the Milky Way galaxy begins. It is a region of space governed by the physics of plasma dynamics and the balancing of immense invisible pressures. To understand this boundary, one must visualize the heliosphere. The sun is not just a source of light. It is a highly active magnetic engine. It continuously ejects a stream of supersonic plasma known as the solar wind. This plasma is composed of highly energetic protons, electrons, and alpha particles traveling outward at speeds exceeding 400 kilometers per second. The solar wind carves out a massive protective bubble within the interstellar medium, inflating a domain that extends far beyond the orbits of the outermost planets. This bubble protects our solar system from the high-energy radiation of the broader galaxy. But as the solar wind streams further from the sun, it encounters the inverse square law of fluid dynamics. The plasma spreads out across an ever-increasing volume of space, and its density drops precipitously. By the time it reaches 80 astronomical units, the wind has thinned to a mere fraction of a particle per cubic centimeter. It begins to lose its momentum, its outward pressure faltering as it encounters the cold, dense resistance of the interstellar medium, the gas and dust that fills the spaces between the stars of the galaxy. The first structural manifestation of this encounter is the termination shock. This is a massive, permanent shock wave that wraps around our solar system. Here, the solar wind undergoes a sudden, violent deceleration. It drops from supersonic speeds to subsonic speeds in an instant. As the plasma slows down, it bunches up, becoming highly turbulent, compressed, and significantly hotter. Pioneer 10 crossed this invisible wall of turbulent plasma silently in the late 1990s. Its deactivated instruments unable to record the sudden spike in magnetic turbulence and plasma temperature. Beyond the termination shock lies the heliosheath. This is a vast, transitional netherworld where the solar wind no longer blows straight outward. Instead, it is deflected backward by the pressure of the oncoming interstellar wind, streaming down the tail of the heliosphere like the wake behind a ship. In this region, the solar particles mix with neutral hydrogen atoms leaking in from the galaxy. The environment is a chaotic soup of magnetic fields and low-frequency radio waves generated by the friction between two completely different stellar environments. The final boundary is the heliopause itself. This is the definitive interstellar shoreline. At this exact interface, the outward ram pressure of the dying solar wind is perfectly balanced by the inward thermal and magnetic pressure of the interstellar medium. The interstellar medium is composed of the cold, dense plasma remnants of ancient supernova explosions, mixed with galactic magnetic field lines. When a spacecraft crosses this threshold, it leaves the solar plasma behind and enters true interstellar space. The ambient particle density instantly increases, and the composition of the environment shifts from solar hydrogen to pure galactic cosmic rays. Pioneer 10 and Pioneer 11 are moving across this threshold right now. They are crossing an invisible cosmic border, entering a realm where the sun is no longer the dominant physical force. They are swimming in the ancient galactic tide of the Milky Way. The vacuum here is colder, denser, and filled with the background radiation of 100 billion stars. The silent twins have completed their crossing of the solar system's perimeter. They are now true interstellar travelers, drifting through an absolute, pristine isolation that will remain undisturbed for millions of years to come. Pioneer 10 is moving through the absolute dark, traveling at a quiet, unyielding velocity of approximately 11.9 kilometers per second. It has left the boundary of the heliopause completely behind, entering the pristine, undisturbed cold of the interstellar medium. The spacecraft is heading in a highly specific direction, aimed toward the stars that form the ancient, celestial outline of the constellation Taurus, the Bull. It is a journey measured not in miles or in years, but in vast, incomprehensible epochs of deep time. Ahead of the silent probe, spanning trillions of kilometers of empty space, lies its ultimate, distant destination, the red giant star known as Aldebaran, Alpha Tauri. Consider the profound scale of this trajectory. Aldebaran sits at a distance of approximately 65 light-years from our home world. To a human eye looking up from the Earth, it shines with a distinct, baleful, orange-red hue, marking the fiery eye of the cosmic bull. This specific coloration is a direct manifestation of stellar spectroscopy and advanced nuclear astrophysics. Aldebaran is a star of the spectral class K53. This classification indicates that it is a giant star that has evolved completely off the main sequence, having exhausted the vital hydrogen fuel supply within its core. Because the core ran out of hydrogen, the inward pressure of gravity overcame the outward radiation pressure, causing the core to collapse. This intense gravitational collapse generated immense heat, igniting a shell of hydrogen burning around the core, which forced the outer layers of the star to expand outward across millions of kilometers of space. As the outer envelope of the star expanded, its total surface area increased exponentially, causing the energy to distribute across a vast domain. This expansion resulted in a significant cooling of the star's surface temperature, dropping it down to approximately 3,900 Kelvin. According to the laws of blackbody radiation, a surface at this specific temperature emits the vast majority of its light in the longer, less energetic wavelengths of the electromagnetic spectrum. When we analyze the light of Aldebaran through a spectrometer, we observe deep absorption bands of titanium oxide and numerous neutral metal lines. These chemical elements in the stellar atmosphere selectively absorb the shorter, more energetic blue and violet wavelengths of light, allowing only the long, heavy, orange-red photons to escape into the vacuum. It is into this massive, glowing crimson envelope that Pioneer 10 is slowly falling. The space between our Sun and Taurus is not a pure, empty vacuum, but rather a complex landscape of low-density interstellar matter. As the dead spacecraft drifts, it must pass through the outer perimeters of massive, dark molecular clouds. These regions are dominated by the phenomenon of interstellar extinction. The space is populated by microscopic dust grains composed of carbon silicates, polycyclic aromatic hydrocarbons, and thin coats of water ice. These submicron particles are incredibly sparse, yet over trillions of kilometers they exert a measurable physical effect on the light traveling through them. They scatter and absorb the shorter wavelengths of starlight, a process known as interstellar reddening, making the distant stars behind them appear deeply flushed and dim. Pioneer 10 moves through this hazy, silent medium completely unaffected by the dust, its aluminum hull riding the silent gravitational tides of the galactic disk. The spacecraft experiences the phenomenon of stellar parallax in slow motion. Over thousands of years, the familiar configurations of the night sky begin to warp and dissolve. The constellations that human civilizations have used for navigation for millennia slowly lose their geometry. Nearby stars shift their relative positions due to their own independent proper motion across the galaxy. The three stars of Orion's belt begin to drift apart, and the clean V shape of the Hyades cluster, which sits near Aldebaran in the sky, stretches into an unrecognizable alignment. The probe is moving through a changing canvas, a slow-motion geometric dance of stars turning around the central hub of the Milky Way. The timeline for this journey requires a complete surrender of our human relationship with time. Pioneer 10 will not pass near the vicinity of Aldebaran for another 2 million years. 2 million years of absolute stasis. During this immense span of time, the spacecraft will remain completely undisturbed by external forces. There is no atmospheric friction to slow it down, no liquid water to cause oxidation, and no geological activity to disrupt its mechanical components. The probe exists in a state of perfect structural preservation, a tiny aluminum capsule holding a snapshot of 20th century human technology, floating silently through the dark molecular lanes of Taurus, moving step by step toward the dying crimson light of an ancient star. While its identical twin drifts toward the orange eye of Taurus, Pioneer 11 is charting a completely different course through the infinite dark. Because it used the immense gravity well of Saturn to execute a high inclination gravity assist, the spacecraft was slung upward, out of the flat, crowded plane of the solar system's ecliptic. It is ascending into the northern celestial sky, moving along a trajectory that aligns with the galactic coordinate system's higher latitudes. The probe is traveling toward the stars that comprise the constellation Aquila, the Eagle. The two silent twins, built by the same human hands in the same clean rooms on Earth, are now separating from each other at an ever-increasing distance, moving into completely different quadrants of the galaxy, destined never to meet again. The region of space that Pioneer 11 is entering is marked by a deep contrast to the path of its sister craft. It is moving toward the dense, rich star clouds of the intergalactic plane, where the stars of the Milky Way crowd together in a brilliant, luminous band across the sky. Yet, between the spacecraft and those distant stellar clusters lies a massive cosmic structure known as the Aquila Rift. This is a vast, interconnected system of dark nebula consisting of cold, dense molecular gas and interstellar dust that completely obscures the light from the galactic core. The dust grains within the Aquila Rift are composed of complex iron-magnesium silicates and carbonaceous soot. These structures cause severe Rayleigh scattering, where the tiny particles selectively deflect shorter wavelengths of light, completely blocking the visual spectrum and leaving a deep, black silhouette against the glowing background of the galaxy. As Pioneer 11 enters this dark corridor, it is moving through an environment defined by stellar kinematics and the complex orbital dynamics of the galactic disk. Every star in the constellation Aquila is moving along its own independent galactic orbit, turning around the distant supermassive black hole at the center of the Milky Way. The probe's path is a manifestation of pure inertia, governed by the initial kinetic energy it received from the launch rocket and the subsequent gravitational energy it stole from Jupiter and Saturn. It is falling through a gravitational potential well that is continuously shifting as nearby stellar systems pass by at distances of multiple light years. Their subtle, invisible gravitational fields tugging gently on the spacecraft's small mass. The destination of Pioneer 11 is not a single, specific star, but rather the general stellar fields of the Eagle. In approximately 4 million years, the spacecraft will pass within the proximity of one of the stars that form the Aquila constellation. During this multi-million-year transit, the probe will pass near several active H2 regions. These are massive clouds of ionized hydrogen gas, glowing with a vibrant, ethereal blue and violet light. The spectroscopy of these regions reveals that they are stellar nurseries, where high-energy ultraviolet radiation from newly formed massive O and B-type stars is actively ionizing the surrounding hydrogen gas, stripping electrons from protons. When those free electrons recombine with the protons, they cascade down through energy levels, emitting characteristic photons at specific frequencies, including the brilliant crimson line of hydrogen alpha and the deep ultraviolet transitions. Pioneer 11 skirts the edges of these brilliant, glowing clouds, a dead, black silhouette passing through an ocean of ionized gas. The spacecraft's 4 SNAP-19 nuclear generators are now completely cold, the plutonium-238 having decayed through multiple half-lives until only a stable, inert isotope of lead remains. The thermocouples are silent, no longer generating even a fraction of a millivolt of electrical current. The electronic components inside the central equipment box have dropped to the ambient temperature of the deep vacuum, sitting at roughly 3 degrees Kelvin above absolute zero. The copper wiring, the silicon wafers, and the fiberglass circuit boards are frozen into a state of absolute crystalline immobility. Consider the isolation of this flight. Pioneer 11 is moving through a domain where the average distance between individual atoms of gas is measured in centimeters. It is a vacuum more perfect than any environment that can be created in a laboratory on Earth. The silence is total, absolute, and unbroken. There is no sound because there is no molecular medium dense enough to transmit a pressure wave. There is no light within the interior compartments of the craft, only the external starlight casting sharp, hard, unsoftened shadows across the parabolic dish antenna. The probe drifts onward, an unguided, unpowered ghost ship sailing through the dark nebula of the Aquila Rift, tracking its own slow, independent path across the deep architecture of the cosmos. As the millions of years blend into billions, the Pioneer twins transition from active historical artifacts into the realm of cosmic archaeology. They are now among the longest-lived structures ever created by the human species. Long after the oceans of Earth have evaporated due to the gradual brightening of our aging sun, long after the monuments of human civilization have been ground to dust by tectonic activity and atmospheric erosion, these two small spacecraft will continue to drift through the interstellar void, carrying the pristine, unaltered record of our existence. They are monuments built to survive the end of the world. However, the deep vacuum of space is not a completely benign environment. Over vast spans of evolutionary time, the spacecraft must endure the slow, cumulative effects of cosmic erosion. The primary mechanism of this erosion is the phenomenon of sputtering, caused by continuous exposure to galactic cosmic rays. These rays are not rays of light. They are highly energetic atomic nuclei, mostly isolated protons and alpha particles, traveling through the galaxy at relativistic speeds, accelerated by ancient, violent supernova explosions. When one of these high-energy nuclei collides with the aluminum skin of the spacecraft, it initiates a process of microscopic kinetic ablation. The incoming cosmic ray nucleus penetrates the outer layers of the metal, transferring its immense kinetic energy directly to the atoms within the aluminum crystalline lattice. This impact causes a localized disruption, knocking individual aluminum atoms out of their structural bonds and sending them flying off into the vacuum of space. It is a slow, atom-by-atom sandblasting, occurring with a cold, relentless regularity over hundreds of millions of years. This continuous spallation and sputtering will slowly erode the outer surfaces of the craft. The brilliant, polished sheen of the parabolic dish antenna will gradually dull, its surface transforming from a smooth, reflective mirror into a microscopic, pitted matte texture that scatters starlight in random directions. Simultaneously, the spacecraft must navigate the hazards of hypervelocity impacts with micrometeoroids and interstellar dust grains. While the space between the stars is incredibly sparse, the immense velocities involved mean that even a microscopic particle of silicate dust, possessing a mass of less than a microgram, carries substantial kinetic energy. When such a particle strikes the spacecraft, the energy of the impact is converted instantly into heat and shock waves. The dust grain and the target metal are instantly vaporized, creating a tiny, symmetrical circular impact crater surrounded by a minute lip of molten and resolidified aluminum. Over billions of years, the smooth panels of both Pioneer X and XI will become heavily textured, covered in a complex matrix of overlapping impact pits, a physical diary of every microscopic particle they encountered during their journey through the galactic disk. Yet, despite this continuous microscopic battering, the gold anodized aluminum plaques carried by both craft are uniquely shielded from the worst of the devastation. Mounted flush against the central structural framework, protected by the massive bulk of the high-gain antenna dishes, the plaques are largely insulated from direct hypervelocity dust impacts. the gold anodization layer, created through precise electrochemical processing, provides an exceptionally stable, non-reactive barrier, while cosmic ray sputtering will slowly, over 1 billion years, reduce the thickness of the plate by a few micrometers. The deep geometric etchings of the pulsar map and the human silhouettes will remain entirely legible. The universal clock of the hyperfine hydrogen transition will still speak its mathematical truths to anyone who might find it. Consider the ultimate fate of these silent pathfinders. They have become permanent citizens of the Milky Way galaxy. They are bound to the galaxy's gravitational potential well, orbiting the galactic center once every 250 million years. They will complete multiple full revolutions around the core of our galaxy, riding out the slow, structural changes of the galactic arms. They will watch from afar as new stars are born within dark molecular clouds, and old stars collapse into white dwarfs and black holes. They are two small, message-bearing seeds cast into an infinite, turning ocean of stars. Let your mind rest on this final image of absolute permanence. The silent twins, Pioneer 10 and Pioneer 11, drifting completely cold, completely dead through the pristine, eternal vacuum. They are separated by light years of space, yet unified by their shared origin. They carry the lineaments of our faces, the coordinates of our home, and the fundamental physics of our universe out into the infinite dark. They are human thought made physical, frozen in metal and gold, traveling forever across the ultimate silent horizon.